Hi students, now we'll talk about section 3.4, which is a circular motion. For example, we have almost the moon rotating around the earth because we have for this system attractive force, which is the gravity, which attract moon to earth and earth to moon. And the motion of the moon is a circular, and the velocity of the moon is tangential to that circular track. For example, to understand this, if we have a moving body in a circular motion and the radius of this circular track is r, maybe it be r small or r capital. If we have now two velocities, v0 and v1, but the speed is the same. What is the difference between velocity and speed? The speed is the magnitude of that velocity. It is the same. Maybe it is 10 here and 10 here, 5 here and 5 here, but the velocity is different because the direction of this speed is different than the direction of this speed, because we are talking about the velocity, which is a vector. What if we need to find the change in velocity? We have, this is the initial velocity and this is the second after a period of time, and the change in angle from the first point and the final point is delta theta. The total angle is 360, as we know. What is the change in velocity? It is v1 minus v0, or v in final minus v initial. This is the vector of change in velocity. Look now between the change in velocity between the initial and the final point and the direction of that change in velocity. If we make that period of time shorter, then we take another points between v1 and v2, for example, with smaller theta, and we will see that the difference in velocity is changing the direction, because we have now two velocities and we converges them to other. This is the third one. What if we have, for example, a velocity and we take dt net, not delta t, we have d theta, or also we have dt after a short time. Then the two vectors v1 and v2 will be almost the same, and the direction of the change in velocity will direct to the center of that circle. Look here, we have v1 in red, v2 in purple, and when they come to be at the same point, almost beginning point, then the direction of the change in velocity will direct to the center of rotation. Okay, this is just to understand why is the next concepts will appear like it is. During delta time, or dt goes to 0, we have dv, change in velocity, and this dv will point to the center. If we have change in velocity and we have change in time, then we have acceleration. The acceleration will be a vector, and this vector direct to the same direction of dv. In this case, dv is a vector and a is a vector. dv direct to the center of rotation, also the acceleration direct to the center of rotation. This acceleration to the center of rotation called a centripetal or a radial. So when the moon rotates around the earth, there is an acceleration toward the center of rotation. This acceleration a radian is equal to, we can derive this formula, but it is easy. It is equal to v squared over r. You can see that in paper page 82. V squared over r. V is the velocity that the body moving around the center of rotation over the radius. We are dealing with constant speed but changing velocity. If the velocity is changing in its magnitude, which is a speed, or in its direction, then we have acceleration. Now the speed is the same, but the direction of the velocity will changing, and for that we have acceleration. Because the speed is the same around this circle, then we call this motion uniform circular motion. Uniform circular motion, because we have non-uniform circular motion when the speed is changing. Okay, for constant speed we have uniform motion. Now again, the circumference of the circle or the track is 2 pi r. The time period to rotate a total rotation is t capital, which is period. We call t capital period of rotation. So the velocity which is changing, or the speed which is constant, the speed which is constant is equal to the distance divided over the time. We know this formula. The distance is s, which is 2 pi r. The time is the total period, which is t capital. If we square it and use we square the velocity, it will be 2 pi, it will be 4 pi squared, r squared over t squared. Now the radial acceleration, what we found from before, which is v squared over r, we now know v squared in terms of t and r. We can use this formula and put it in the place of v. Then we have another formula for a radian in terms of the radius of rotation and the time period. Okay, we can compute in this case t from the acceleration and r. We have two formulas, both of them are the same because we just use geometry, which is 2 pi r is equal to the total distance for this track divided it for t to be the speed. For example, for the moon and the earth system, if the time period for the moon to rotate around the world, around the earth, is 27.5 days, which is the astronomical period, not the earth period. The earth period is 29.5. okay, this is the t capital, which is the total period, and the radius in the average is equal to 385,000 kilometers. Can we find the acceleration between the earth and the moon? And we can also find the speed of the moon rotation. Now the time, which is 27.5 days, I convert it to seconds, which is 2,376,000 seconds. I write it also here in scientific notation. I use E, which is equal to 10 multiplied to 10 to 6. Okay. Also the radius, I write it in the scientific notation, which is 3.85 multiplied by 10 to 8 meters. By using this relation, 4 pi squared is known. R, this is R. T squared, this is T. I need to square it. Then the acceleration toward the center of rotation, which is Earth, is 0.00269 meters per squared seconds, which means this is about 2 millimeters. Yes, it is 2 millimeters. It is just at the width the same as pin width, pin head width. It's almost 2 millimeters or less. This is the acceleration for the moon toward the earth. Means that every second the moon be closer to earth at this distance, by this distance. What is the velocity, or I'm sorry, about what is the speed for the moon rotating around the earth? The speed is equal to 2 by r over t capital, which is the period. It will be approximately 1018 meters per second, which is equal to approximately to 600 not 600 0.6 mile 0.632 miles per second, less than a mile per second. This is the speed of the moon. Okay, now what is the non-uniform circular motion? When we have change in the speed, then we have non-uniform circular motion. If we have initially v1 and then we have v2, which is another speed, maybe it is more or less than v1. V, which is the speed, is not constant. We have another acceleration now. This acceleration, we can call it tangential acceleration, which is the same acceleration that we know from before, change in speed. The acceleration in tangential is different than the radial acceleration toward the center. The tangential acceleration is tangential to the circular track. Okay, now if we look, we have radial acceleration and tangential acceleration. In this case, we have two accelerations and the angle between them is 90. This is the angle between them. This is the angle. They are normal to each other. So we can find a resultant acceleration between them. Using the Pythagorean theorem, the magnitude of the new acceleration or the resultant acceleration, which is A, is equal to square root of AR squared plus AT squared. AR A radial and AT A tangential. Look, this is A radial, this is A tangential. They are right angle triangle. What is the angle theta? What is the direction of that acceleration? If I need to find the angle from the tangential direction, which is theta, or from radial direction, which is phi, I can use tan inverse. tan theta is equal to this side, which is AR over A tangential. So theta is equal to tan inverse to AR or A radial over A tangential. If I need to find phi from the radius, is equal to tan inverse to A tangential over A radius. In our first example, which is Moon Earth system, if the moon changes its speed with acceleration 2 meters per second squared, just the moon be faster, and that's happened. It's natural. Find the resultant acceleration and its direction. We found from before that the A radial is equal to 0.0027 approximately meter per square second, and this is the A tangential. We just need to use the Pythagorean theorem. A is equal to the root of the square of the two accelerations. This will be equal to 0.5018 and something meters per square second. It is near to the A tangential because A tangential way more than A radius. We have a resultant, but it is almost equal to the A tangential, if you see that, because this A radial is small. What is the theta? This is theta. It is tan inverse to A radial over A tangential, which is equal to 0.077 degrees. If we need to find phi, it is the wrist angle, which is 87. No, it is not 87. It is almost the wrist angle, which is shift tan inverse. I will find it to 2 over 0.27. It is 89. There is a typo. 89, not 87, because when we need to add them together, this theta and this phi, the resultant should be equal to 90. This is the circular motion. We have the most formulas. A radial is equal to V square over R. Also the velocity, we can find it using 2 pi R over T. And we will solve another examples. Thank you. Hi students, now we'll talk about section 3.5, which is relative velocity, but I will start with relative velocity in one dimension, in X direction or in Y direction or something like that. Let us understand this concept by doing this example. If we have a bus and we have the road and we have the ground and a person on the ground and a person inside the bus, we need to understand the problem. If we have each thing from these things is moving with a velocity. For the person on the ground, its velocity is v1 because its number is 1. The ground is numbered as 0, so its velocity is 0. Its velocity is v0. But I need to find a reference at the beginning. So my reference in general, it's the ground. So the velocity of the ground, which is named or numbered by 0, with respect to itself, which is v00 or v ground with respect to ground, is equal to 0 meters per second. The velocity of the person on the ground who is walking, for example, or maybe he is standing, and his velocity with respect to ground is v10. Maybe he is standing and at stationary and his velocity is 0 with respect to ground. But in my example, I suppose that v10 is equal to plus 6, means I will move to positive x as positive, negative x as negative sign. Now his motion with respect to ground with velocity plus 6 meters per second. What is the velocity for the ground with respect to ground? It is 0. What is the velocity for the man with respect to itself? I mean v11. It is equal to 0 meters per second. We can find that. What the velocity of the ground v0 with respect to 1, with respect to this man? If the man moves in this direction with velocity positive 6, then the ground seems to move with respect to man with velocity negative 6. So if we change the indices, then we need to change the reference points, and then we need to change the direction or the signal of the sign of the argument. Okay, for the bus I named it 2 and its velocity is v2. Its velocity with respect to ground, which is the reference, is v20. Its velocity to the negative x-axis in our representation. Then I give it a magnitude 10 meters per second, but because it is in negative x direction, I give it a minus sign. So v2 with respect to ground, v20, is equal to negative 10. What is the velocity of the ground with respect to bus? It is v02. V the ground with respect to the bus, it will be positive 10, not negative. So anyone the ground sees the bus moving with velocity negative 10. The bus seeing the ground moving with positive 10 meters per second. So if we are sitting in a car and the car moving to east, and if we look at the ground outside the car, we will see it moves to the west with the same velocity. East and west, positive and negative, the same velocity, 10 and 10. Now if we have a person moving inside the bus, walking for example to the positive x direction, this person named 3, its velocity v3, but his velocity with respect to bus v32. He is moving now inside the bus with velocity positive 3 with respect to the bus. What is the velocity of the bus with respect to that person? It is negative 3. So the person see the body of the bus, which the person inside the bus, moving in the opposite direction with the same velocity. So this should not be weird when we solve numerical examples. Now if I need to find v2, 2 is the bus, 1 is the person. Okay, I need to find the velocity of the bus with respect to person who is moving with velocity 6. Maybe he is running. Now I need to jump between the known velocities. I know the velocity between the bus and the ground, and I know the velocity between the ground and the person. So I can jump between these references. I can't find it directly, the velocity of the bus with respect to person. So I need to find v2 with respect to 1 is equal to v2 with respect to ground plus v ground with respect to person. So I need to find V2 0, then plus V0 1. V2 0 is negative 10. V0 1 negative 6, the velocity of the ground with respect to person. Then the total velocity will be negative 16. So the person sees the bus moving to the negative x direction with negative 16 meters per second. If you look to the indices, I need F21 between, so I find, look at these indices here. I have 2 0 0 1. If you hide the zeros, you will find 2 1. I have 2 1. I start with 2, end with 1. I start with 2, end with 1 in the right hand side. Let us look at another example. I need V3 to 0. 3 is the person who is moving inside the bus. I need his velocity with respect to 0, which is the ground. Okay, I don't know it directly, so I need to jump between the known references. V3 is known with respect to 2, to the bus, and V bus is known with respect to ground. So I can move in this way. So V30 is equal to V32, which is known, plus V20. V3 with respect to bus is positive 3, plus V, the bus with respect to ground, is negative 10. So I have plus 3, negative 10, which is negative 7. So the velocity of the person who is walking inside the bus with respect to ground is negative 6. It's negative 7. Negative 7 means he is moving to the negative x direction. Now the bus moving with velocity 10, and the person moving with respect to the right with velocity 3. So I have 10, and I have the person moving with 3. This is minus 10. The total velocity, or the resultant velocity, it will be negative 7 if we add these two vectors together. Again, look at the indices. I start with 3, ends with 0, then I will start with 3 and end again with 0. 2 will be disappeared at the end. Now the longest one, what is the velocity of the person moving inside the bus with respect to the person who is running on the ground? I don't know this velocity directly. I need to jump between these references. I will move from this one to the bus, to the ground, then to the person who is running. Okay, I need to find V3 with respect to 1. I know V32, I know V20, I know V01. V32, the person walking inside the bus in the positive x-axis with 3 meters per second. Also V20, the bus is moving with negative direction 10 meters per second. V01, the velocity of the ground with respect to the person on the ground running, is negative 6. Then the resultant velocity between the resultant velocity for the person inside the bus with respect to this one is negative. This one sees this one moving to the negative direction, but 13 meters per second. Again, look at the indices. I need V31. I start V32, V20, V01. 2 will go with 2, 0 would go with 0. I start with 3, end with 1. This is the relative velocity in one dimension. I will move in the next part to the relative velocity in 2 or 3 dimensions. Now I will talk about the second case, which may be seen more complicated, but it is not. We have many motions in 2 dimensions, and you can apply that for the motion in 3 dimensions. We can find the relative velocity in any dimension. For our case, if we have a river and the riverside, we have the velocity of the ground, we have a fisherman with a velocity as a vector, the velocity of the ground as a vector. All of velocities are vectors now. We have the xy plane. This is the x direction in positive direction. This is positive y direction. We have a boat with this velocity, for example, just a drawing. We have a sailorman inside the boat. He has his velocity. We have river's velocity. We don't know what is each one of these velocity and with respect to another. These are a given in my question. If we have the velocity of the ground with respect to ground in 2 dimensions, I and j, because we are in a plane now, not in 3D. But you can apply this concepts for 3D. The velocity of the ground with respect to ground is 0 in I direction, in x direction, and 0 in j direction. So it is stationary with respect to itself. Okay, and if we take the inverse, it's the same. What is the velocity as given of the fisherman with respect to ground? It is -2 in I hat, -1.5 in j hat. If we take the inverse and we need to know what is the velocity of the ground with respect to the fisherman, we just need to exchange the signs and the same speeds. The speed is 2 in I direction and 1.5 in j direction or in y direction, but we have change in directions. Okay, what's the velocity of the boat with respect to the river? The velocity is -5 I hat plus 3 j hat. What is the velocity of the river with respect to boat? It is the same speeds but with different direction or opposite direction. It will be not -5, +5 I hat, -3 j hat. What's the velocity of the river with respect to the ground? The river is in this direction, just in x direction. As I give you here, it's 10 I hat plus 0 j hat. What's the velocity of the ground with respect to the river? It will be -10. The velocity of the ground is in negative direction of the river, plus 0 j hat. What is the velocity as given? I give you, it is a given, the sailorman with respect to the boat, inside the boat. It's 1 I hat plus 2 j hat. What is the velocity of the boat with respect to the sailorman? It is -1 I hat, -2 j hat. Is that understood? Now we have all the velocities and we can find the velocity for any object with respect to any other object. We can connect the indices and find the relative velocities. Remember that if we need to find, for example, V14, then we need to jump between the indices. So this will be equal V12, V23, V34. Then all the inner indices will cancel, but we have the first and the final index. If we have vector components, then it's easy. We just need to deal with x components alone and y component alone. For example, this is our problem. What if we need to compute v, the velocity of the sailorman with respect to the river? This is the sailorman, this is the river. We need to compute the velocity of this man to the river. It's easy. v of the sailor man with respect to boat, which is known, plus v of boat with respect to the river, which is known. We need just to put the given velocities as vectors. We know them. Then add x component together. It will be -4 in I hat and 5 in j hat. This is the velocity for the sailor man with respect to the river. Okay, next. What's the velocity of the boat with respect to the fisherman? This is the boat, this is the fisherman. What is the velocity? We have not straight in x or y direction for both of them. We know the velocity of the boat with respect to river. We know the velocity of the river with respect to ground. We know the velocity of the ground with respect to the fisherman. I just reverse these velocities to find to change the references. Then I put the velocity vector for each one of them, and add then the x components, the y components. Then I find the velocity for the boat with respect to the fisherman is equal to 7i plus 4.5j. Moreover, what is the velocity of the sailor man with respect to the fisherman? It's easy. I need to find this relation. This is not unknown, but I know these velocities. I know velocity for the sailor man with respect to the boat, and the velocity with respect to the velocity of the boat with respect to the river, plus the velocity of river with respect to ground, and the velocity of the ground with respect to the fisherman. All of them are known as vectors, and these are the velocity vectors. This one, we need just to add the x component together, which is 8i, and the y component together, which is 6.5j. This is the velocity vector for the sailor man with respect to the fisherman. If we need to find, for example, velocity fisherman with respect to the sailor man, it will be equal -8, just the same speed but change the direction. I hat plus -6.5 j hat, and that's it. If we need to know to find the total speed, for example, just the speed VSF as a speed, as a magnitude, it is equal to Vx squared plus Vy squared, as known, which is the Pythagorean theorem. It's easy. And also we can find tan theta is equal to Vy over Vx, which is also known. Then theta is equal to tan inverse to Vy over Vx. This is the relative velocity in 2 dimensions. We use river, boat, ground system. If we have velocity in 3 dimensions, for example, we can use an airplane. Then we have x, y, and z, and there is a person who is moving inside the plane in 2 dimension or 3 dimension, or something falling from the inside the plane in 3 dimensions. Then we can find the velocity which for an object with respect to any other object, even if it is at the earth, at the ground. But we need to know the connecting indices to move from an object to a final object. Thank you.